2 months ago, I was actually looking at a report from BCG Consulting. And what they've done is they've interviewed 60 CEOs from various different industries in process. And what they were trying to understand is how are companies generating value from digital. And one of the key metrics that they were looking at was how many of those companies were able to scale value from digital solutions at an enterprise level. And the results were very shocking. Any guesses? What percentage of these companies do you think have realized value at scale at an enterprise level? Any guesses? How many of you think it's more than 50%? Not many? Okay, one. How many of you think it's more than 20%? Okay, several. Okay, how many of you think it's more than 10%? A lot more, okay. Now, the answer is actually neither of them. The answer is 5%. It's only 5% of the companies are able to scale value at an enterprise level. And this was a very shocking number, given the fact that all of us in the industry have been investing into digital solutions for the past, almost 10 years, right? And so when I looked at that, I thought, maybe I want to share some of my thoughts around this. And so today, I'm going to be talking about this topic. So we're going to talk about 3 things. One, why are organizations not able to scale value with the digital solutions? Second, we're going to look at what are AI reasoning agents and how can this technology unlock that problem? And third, we're going to look at real-life examples and use cases so that you all can see how that technology may be applicable in your own day-to-day work. Okay? With that, I am Jagadish Gattu. I'm the founder and CEO of UptimeAI, based out of San Francisco. We are essentially an AI software company focusing on improving profitability of process industries. And we're essentially a group of subject matter experts, very senior experts from OEMs and operations, along with people who know AI and industry leaders like myself, applying AI specifically to operational issues. And we have offices in Dubai and Oman, and we work with some of the industry leaders like PDO, OQ, and others, Viva and others. So first topic. Why are digital tools not able to really scale up, right? Scale up to the ambitions of the enterprise leaders. The first challenge is essentially digital tools. The more tools you add, what do you need? More to scale the solution or the value. You need more experts and more people. Isn't that true? Now, I was actually talking to a chief digital officer of an oil and gas company. What they've done is they've actually taken maybe 10 equipment, 15 equipment, and they've deployed a solution. And they found some value for those on that deployment. And the digital officer said, okay, they called the reliability director and they said, how many equipment do we have? They said, well, we have close to 500,000 equipment. And he said, why don't we essentially, scale the solution to maybe 5,000 equipment? And the reliability engineer or the director looked at him and said, we can't do that, because if you want to do it, we need 50 engineers who are looking at all these, all the alerts to fine-tune the models and then, maintain the alerts, et cetera. And this is the problem that we're seeing in the industry, that the more tools you add, the more experts you need. And I don't believe everywhere we're seeing that there is a shortage of experts and we're not actually growing, increasing numbers. The second problem that we see is there are too many digital tools, right? I mean, we see a lot of digital tools and separate point tools. You have one for lubrication analysis, one for vibration, one for ultrasonic, and then so many of these. Now they're all adding value, but the challenge is how do you bring everything together and essentially understand the reason and take that in action. And that again requires more experts. And so what we see is the challenge for scaling these solutions to uncover more value is basically limitation with the number of experts. So what does this mean? Why is this so important? Where are we losing opportunity because of this? So for example, if you want to monitor a lot of auxiliary equipment because the critical equipment are already monitored, right? We again, limitation with people. Why not do more RCA? I mean, you find issues, you find problems in the operations, and you want to actually look at, what's causing it. But every time you want to do RCA, and we were looking at the process of, the different aspects that need to be considered in the RCA. And every time you want to do RCA, you need more people. We don't do enough, right? Similarly, there is criticality analysis, there is maintenance strategy, there is, spare strategy. So all of these, if you want to keep doing it more frequently, more extensively to identify more value, you need more and more experts. And this essentially is a limitation that limits us from delivering the results. So now coming to how can we unlock this challenge? And this is where we're talking about reasoning agents. So what are reasoning agents? So first, we all have data, and I'm sure the industry, we have many different types of technologies that we're all using. And each one of these technologies is providing different types of insights. Now the challenge, as we discussed, is how do we channel all these insights and give us an answer or an action that we want to do? And that's what reasoning agents are doing. Reasoning agents are nothing but they are trying to mimic what an expert does, and each reasoning agent has its own domain skills. Meaning, like an expert, if you want to do an RCA, you want to have someone like you mentioned, like the previous speaker mentioned. You need to have so many competencies and expertise, right? You want to understand, how to look at PNID. You want to understand criticality. You want to understand failure mode analysis. You want to understand trending analysis. So each agent is basically equipped with these kind of skills, so that the agent knows how does it apply all these skills to give you an answer for an RCA, for example. So we have several of these. So you can see we have you can have an RCA agent, you can have a maintenance optimization agent, you can have a HAZOP process optimization, and there can be more, right? But all of them are relying on the same domain skills and the competencies that we come to know as the industry, from the industry. Now, what we're going to do next is we're going to look at some examples. Are these real? Are they actually working? Can you actually see them in action? And so let's take some examples and see how they can be practical. So this is a case study. So there was in a petrochemical plant. So there was essentially a compressor that was tripping repeatedly, multiple times. They knew that there was a problem, but they were trying to identify why is it happening consistently, right? And so while they knew they could see the problem happening, but they were trying to understand why. Now, a good root cause can actually help us in terms of understanding how you can improve, right, what is causing. And in this case, the cause was, the root cause was composition change. The composition change in the feed rate, or in the feed, was actually causing changes in the reactor, and the gases that were coming out were actually going to the compressor, and that was causing the problem in the compressor, causing trips. Now, this root cause is essentially important because if you understand the root cause, then you could better control the process. That would improve the yield, and as well as reduce the number of trips. Now, this is a complex, exercise for someone to go through and spend, weeks and months trying to analyze the data. What a RCA agent can do is essentially produce a report automatically to help assist the engineer in terms of understanding what is the root cause. So, for example, here you can see that it is generating a report, all of this automatically, showing step by step what sensor. And in this case, it's showing the composition information, how it's increasing, how that actually is causing an issue in the reactor, and how that's ultimately contributing to the compressor trip. It not only does that, but it also shows clear evidences, including connections to work orders, documents like SOPs, manuals, etc. Gives you recommendations, and all of it in an automated way in just an hour versus weeks and months of work. And the final part is, it's not a black box. It's not something that you get and you can just take it for what it is. You also have essentially ways that you can interact with it. You can ask questions. You can try to understand why it's doing and what it's doing. So you can ask a question about what is a reflex element, etc. And you can ask, can you explain to me how this is actually causing it? Can you show me graphs on how these are correlated to the data? And you can ask a lot of these additional questions. So it's much more interactive, like a human expert. So what are we doing with it? So I know we, as an industry, we have been trying to go up and up, right? Initially, we wanted to go from the PF interval going even earlier, trying to understand functional failures. Then we started understanding trying to go even further. And now we have an opportunity to go even further, try to understand the root cause even before it actually even happens, right? And this going to the root cause is generating much higher value. And this is one of the ways in which organizations can generate more value from the new technologies. I have one more example with a maintenance optimization agent. What does this do, right? So what we're looking at is, again, another case study here. So there was essentially a gas plant trip at one of the upstream or midstream facility. And that actually caused a deferment of about maybe $15 or $20 million of lost revenue. Now, when they did the RCA, what they found was a valve which did not have the right maintenance strategy. There were some changes in the equipment or the design. They've added some or they've removed some, and essentially no one went back and changed the maintenance strategy for this control valve. And so why did this happen? Because we have maintenance strategies, but they're mostly stagnant because the company that we're working with, they have about 1 million F-locks, right? They have 1 million equipment. How are we going to change the maintenance strategies for those frequently, every 6 months? Can we do that? Already we have spent 2 years, 3 years doing maintenance strategy for the entire organization. So if you want to do it every 6 months, it's not even feasible. And also, these are extremely expensive in terms of looking at the maintenance strategies and updating them. So this is a challenge. Now, what does a reasoning agent can do? Reasoning agent is able to look at your criticality analysis. Maybe you already have your criticality for different equipment, right? You have the PNIDs, you have the PM checklist, you have essentially your bundling, your cost of failures, your spares cost. All of this can be taken by an agent and then produce an optimal schedule for you, or a recommendation for an optimal schedule, so that you can see, okay, you know what? I'm going to change your maintenance strategy for this equipment, and that's what I'm recommending. And the expert then can look at that and understand, why is it saying that? It's actually showing you all the calculations, which are ADA, like viable analysis and other types of analysis, in an automated way, continuously, every month, every 3 months, every 6 months. You can actually get that analysis done and show what is the cost benefit of either decreasing the PM, increasing the PM, and so on. And again, you have also an agent should be able to also explain what does that mean. So it should be able to explain how you can, what does this mean? Instead of changing it to 75 days, what happens if I change it to 50 days? How is that going to impact my maintenance? How is it going to impact my risk? And so all those questions could be asked, again, from a chat or a co-pilot type agent. And this is what the power of an agent brings. So I want to conclude it by saying that the scalability is a factor of the expertise that we can apply to solving these problems. And we know that there is a lot of data, and there is a lot of operational opportunities that we can all improve. But unless we scale the expertise, we're not going to be able to really take those or realize those savings. And so we know that AI is not really trying to take the job, as is shown the example of how AI can append the experts that you are and essentially give you a lot more bandwidth in terms of taking on more things that today are not even addressed. And what you can do in weeks can be done in hours, and that's the power of these agents. So with that, I want to conclude, and I want to thank the team for giving us this opportunity, and I'll move to the questions.
Any questions for Jagadish? Okay, I have one of my own. Yeah, we have one here. Okay, the mic, please, over there. Hello.
Hello, good morning.
Morning.
Thank you for the good insights about AI and maintenance aspects. I just want to know, the reasoning of AI for the what you call the breakdowns and avoiding breakdowns, all these things. Is there any thing which is being developed or already developed when a plant or a factory is being constructed, so that AI should tell us that, okay, selection of equipment, I mean to say that you take this particular valve give you a good longevity or durability or maintenance free aspect, so that you can minimize your OPEX or maintenance budget in future. So this kind of AI has been already in place, or it is being developed, or can you just throw some light on that?
Thank you. By the way, if you can introduce like which company, that would be helpful.
I am from IFCO Group. Okay.
Okay.
I am the engineering head in one of the IFCO Group BUs.
Got it. Thank you. Thank you for asking the question. If I understood correctly, what you're asking is, when someone is commissioning the plant or the unit, how can we have a better understanding of what are the elements or what are the equipment that could be covered as part of the technology to generate more value? Is that correct? Yeah, it's a great question. The way the technology is moving, we are looking at covering the entire units, the full unit, right? And so it's not about a specific equipment, because most of the organizations, they want to scale the value. They want to scale the value across the entire organization. And how do you scale the value? You have already covered looking at the most critical assets already. Mostly most of the companies are already doing that. Now the question is, how do you take that even further, even beyond those, right? And so most of the time, the auxiliary equipment and the supporting process equipment is key in terms of uncovering hidden value, right? And so the approach that we take is we can take a full unit, and the agent can cover a full unit. It can do that because it's much more automated. It can not only look at your sensor data, but it can look at your maintenance issues, you can past issues, your SOPs, your criticality analysis. And that is all, because it's automated, the cost of covering more equipment is lower, and you can generate much more value. So I would almost say that the best practice, as and this will happen in the future, is going to be able to cover full units comprehensively, and not just an individual equipment. Question there.
Good morning. Thank you, Jagadish, for the presentation. I just have two questions. The first question is how well does the AI reasoning deal with other platforms of a refinery, for example, warehouse inventory management? Does it track the spares, withdrawals, and then analyze that data and just creates a strategy based off that information? And the second question is regarding the sorry, I forgot. Let's just answer the first question and then I'll go back to the second.
So the question is, can the agent look at your inventory or spares, information to also then update your maintenance strategies, right? Yeah. So absolutely, because and that's the advantage of an agent, because the more skills you can append to the agent, right? In terms of looking at the spares information, at the end of the day, it can then look at, okay, you know what? You're having these corrective maintenance actions and you're replacing the components, and what is the cost of that component? So ultimately, the general way to look at it is, how many spares do you have in the, available in the inventory? And if you are actually replacing only one every year, but you have 5, right? The cost of the spare is essentially a factor of how many, or cost of the component is a factor of how many spares you have. So the agent will look at that information and take the spares cost to also consider how it should optimize the maintenance strategy. Absolutely.
Okay, thank you. The second question is, have you had practical, experience with bad actors elimination in cross refinery or a plant? So how well does that work with eliminating those bad actor equipment?
So the question is, can the agent understand the bad actors and then,
Yeah, basically based on the information that you feed it, it would create a list of, let's say, it will identify bad actor equipment that are, frequently repeating. Or there are sometimes silent bad actors that are very hard to detect. So how well will the AI deal with that? And have you had practical examples where you've had these issues in a plant or refinery and you were able to eliminate those? Yeah,
absolutely. We've had the agent. When you want to automate the maintenance strategy updates, you can either select by let's say you can select this unit only criticality B equipment, right? Or you could say, run it on my bad actors, right? And it will show you which ones are the bad actors based on the cost, right? And when you apply that, it also is able to then look at how are we identifying the challenge. So, for example, one of the companies, they had a bad actor with a crusher. This is a metals and mining type of company. They have crushers, and the crusher was a bad actor because it was actually failing repeatedly. And so the agent was able to look at the bad actor, see how many PMs are being done, how many corrective maintenance actions are being done, how many failures are actually happening. And then, number one, it was able to run the RCA agent to then understand what could be causing this problem, number one, the first part. And then the second part, what they observed was the issues were happening because, of moisture, right? That was the root cause. And they confirmed the root cause from the RCA agent. And then they said, I can't change the moisture in the material because that's what we're getting. And so then the maintenance agent, what it did was it was able to then say, okay, in that case, it adjusted the PM schedule so that you could actually reduce the failures. And for adjusting the PM schedule, the agent was able to do the Weibull analysis. It was able to calculate what is the ETA, what is the correlation between the PM and your corrective maintenance, right? Can I increase my PM? If I increase my PM, how is it going to impact my corrective maintenance? And it produced a report that was able to taken by the maintenance team and then presented to their management, and then said, this is how we're going to adjust the schedule to reduce the cost of failures of the crushers. Is that yeah. Okay?
Yeah.
Okay, the back. Okay, go ahead.
Yeah, good morning. Thank you very much for your presentation.
At the back.
My name is Hammam Al-Jum'a from KOC.
Okay.
Senior Marine Maintenance Team. I'd like to ask a question. What is the end process? For example, if the agent have fed me with the corrective maintenance, corrective data, would I apply the lesson learned in that agent or this?
Can you please speak a little
yeah.
bit louder? Yeah.
Basically, after the agent have provided me with the all details that is required in order to verify the issue in that unit, would basically feed this application with the lesson learned, whereby it add into this agent knowledge, for example, or basically it after he gave me the corrective answer, it stops.
Great question. So thank you for asking the question. Let me just paraphrase it to make sure I understood correctly. So what you're asking is, once the agent identifies an issue and provides a recommendation, what happens after that? Is it actually you make a correction in the field? Is it learning and is it improving, or is it just static? Is that correct? Okay. Yeah, that's a great question. So agents by themselves, by design, they are building up the knowledge, right? And they are continuously looking at the information and appending this information, not only within the agent, but also in your systems. So you may have an internal system for documenting all the RCAs, right? And so what the agent is doing is, once you have confirmed the issue, it is pushing out the report into your system. That's number one. And every time it's pushing that report into your system, next time when there is a different issue, the agent is also accessing that information and then utilizing that as a knowledge repository to again provide you more references. So the next time you see the same issue, it can say, look at this past RCA. We've already had this issue. You've already fixed this in the past, and now it's a similar issue that is actually being seen. Does that answer the question? Thank you. Thank you for asking.
The mic, please. Last question, yeah.
Thank you. Good morning. Martin Eroche with the ENAC Operations, Senior Project Manager. Can you hear me loud and clear?
Yes, it's you. Jagadish.
Okay, yeah. If you can speak a little bit louder, that would be helpful. Thank you.
Sure.
Yeah.
So how do you mitigate against this AI agent hallucinating? So is it a case of it's only as good as the data that's being fed into it, or is it more of what we've seen with some OpenAI gen tools, ChatGPT, etc., where there's the risk of hallucination and it's not always quite accurate? What mitigation plans are there in place to ensure that this hallucination doesn't, threaten reports, etc.?
Got it. Thank you so much for asking the question. That's a great question. The question is about how is it compared to, or how does it compare with maybe OpenAI or ChatGPT or Gemini, and how do you address issues with those like hallucination? Does that kind of, yeah, okay, perfect. See, the difference between a language model or a large language model, a foundational model like OpenAI or ChatGPT versus an agent. Let's try to make sure that we are clear on that difference, right? A large language model or a foundation model essentially is able to interpret language, interpret documents, interpret words and verbal information, right? That's the language model itself. Now, however, in order to solve problems like RCA or maintenance strategy, just being able to read documents is not enough, right? You should also be able to interpret PNIDs. You should also be able to do optimization. You should also be able to understand FMEA. You should also be able to understand time series data or sensor data, right? And so the fundamental difference is that an agent has more, it is utilizing the large language models, right, as part of one of that skill set, but it also brings other skills which are required in our domain, in our industry, to be able to solve those problems, right? And that's what we're calling as domain skills. And the agent needs to have multiple domain skills, not just the language model. Now, and to talk about the hallucination part, the way the hallucination is minimized, it's not completely devoid, but it's minimized, is because when we design or when a vendor designs an agent, the agent knows how to orchestrate between the different skills to then give you the right answer. So it's not randomly asking ChatGPT, tell me, right? That will give you a lot of hallucination. But the agent will say, okay, you know what, this is a problem. Let me try and understand, is this a redundant equipment or is this a critical equipment? What is the cost of this, the production? What is the impact of the production, if this fails? And then look at what are the past, how is the sensor data, how is the sensor values moving, right? And so it has a way of how it needs to analyze the data, and it's controlled. It's not like OpenAI or where you're just asking a question, you have no idea how it's actually coming up with the answer. And that's why the agents are specifically purpose-built for these type of use cases, and that's why we have multiple agents, right? It's not just one that would solve everything in the world. And that's how we reduce the hallucination. Does that answer the question?
Okay.
Thank you.
I'm sure there are a lot of questions, but Mr. Jagadish and the team, they have a booth outside, so I'm sure it will be a good networking for you to continue the questions. On behalf of the committee, thank you, Jagadish.
Thank you. Thank you, everyone. Thank you. Yeah. Thank you.